Now let's look at the transfer function for the following open circuit. Since this is typical open circuit with positive terminal grounded right here, so we can simply find the transfer function to be minus Z2 over Z1, which is Z2 will be this one right here. This one's Z1. So let's say minus two in parallel. So product divided by summation CS plus R2. Let's know subscript C2, so let's erase this, over Z1. If we further simplify, we get this. And this is a transfer function. So what's the usage or applications in terms of filter? And then we can look at for different type of filter design. If we have low pass filter, meaning the Bode plot, I let the low frequency pass, low frequency, and attenuate high frequency, and band pass meaning I let a band of frequency pass at the attenuate high frequency, attenuate low frequency. If I have a high pass filter, so we can have I pass high frequency component and then attenuate low frequency. So by saying so, meaning for low pass filter, this part right here, I don't have attenuation, but when the frequency goes higher, we attenuate the frequency. For bandpass filter, we attenuate both low frequency component, high frequency component. And for high pass filters, we pass the high frequency and attenuate the low frequency component. So attenuations. This is attenuate. And now back to our original problems. What is the purpose of this filter? Then we just need to check what is the Bode plot for this transfer function. So you simply can draw a Bode plot diagram. Cutoff frequency, in other words, this one with 2 would be tau s plus 1, tau equal to R2 C2. So 1 over tau is 1 over R2, which is a corner frequency right here. And the other one would be R2 over R1, which is a constant. So dB should be 20 log R2 over R1. In other words, another one I have, for this case, one here. So what's total? You add 1 and 2 together, so you will get this overall shape. Up here, it's 1 plus 2. So what's the usage for this type of filter? We call low pass filter. Why? Because we let the low frequency component pass, or you didn't attenuate the low frequency component, but at higher frequency we start to have a decay. That's why we call low pass filters.